The war had already ceased to be merely a succession of battles on distant fronts when the great industrial nations understood that victory would be decided as much by the rhythm of their machines as by the courage of their soldiers at the front. In this new kind of conflict, fought on land, at sea, and in the air, the factory floor became as essential as the airfield, and the silent glow of furnaces at night grew as decisive as the flashes of anti-aircraft fire on the horizon. The Second World War transformed entire economies into engines of continuous production, and ordinary industrial districts into vast complexes devoted to the manufacture of weapons that would leave the assembly line and, poucas horas, cross the sky or the sea, rumo ao combate. What had once been a world of commercial schedules and limited shifts gradually gave way to a system in which the clocks seemed to lose their meaning and the concept of closing time disappeared. Inside these mega factories, day and night blurred into a single, unbroken flow of activity. As we enter this world through the restored images of the 1940s, the first impression is the scale. The camera glides slowly over rows of brick buildings stretching into the distance, their roofs blackened by smoke and time, their windows glowing faintly against the dim sky. Chimneys exhale steady columns of vapor, not in sudden bursts, but in continuous streams, indicating a production that does not pause and does not sleep. Freight trains arrive and depart in regular cadence, loaded with raw steel, aluminum ingots, crates of components, and drums of fuel. Trucks line up at guarded gates, their cargo checked swiftly before disappearing into the maze of internal roads and loading bays. There is no visible sign of hurry, no chaotic rush, yet everything moves with the measured urgency of a system pushed to its limits, designed to function hour after hour, without interruption. Crossing the threshold of one such factory, the viewer is taken from the silence of the exterior into a world dominated by sound. It is not a single noise, but a layered orchestra of industry. The deep, continuous rumble of presses, the sharp rhythm of rivet guns, the whirring of lathes and milling machines, the hiss of compressed air and steam. Over this mechanical background hover voices, instructions, brief exchanges, but no one raises a voice more than necessary. The workers have long grown accustomed to these sounds. They move calmly within them, as if each machine were a large and familiar instrument, performing its assigned role in a composition that repeats itself day and night. Lights hang in long lines from the ceilings, illuminating the floor in a diffuse glow that erases the distinction between morning and evening. The shift may change, the faces at the stations may be replaced, but the process continues uninterrupted. Along the main aisles, overhead cranes travel slowly on steel rails, carrying heavy loads from one side of the hall to the other. Large hooks support bundles of rolled steel, pre-cut sections of spar, engine blocks still in rough form, or even entire fuselage sections already formed. The movement is deliberate, controlled by operators in small cabins high above the floor, their hands resting on levers, their eyes following the path of each suspended piece. Between the pillars that support the roof, long production lines extend in straight, carefully planned paths. At one end, the raw material arrives. Sheets of aluminum, bars of alloy steel, boxes of precision parts, crates tagged with codes and numbers. At the other end, recognizable shapes emerge. Gun barrels, artillery mounts, armored plates, and above all, the elegant yet lethal forms of aircraft components destined for war. The conversion of peacetime industry into this relentless machine of armament did not happen by accident. Engineers, planners, and government officials sat around long tables, spreading out charts and diagrams that mapped every stage of production. They calculated how many tons of steel, how many hours of machining, how many rivets and bolts would be necessary for each airplane, each tank, each gun. They divided the work into segments, assigning different factories to each task, one dedicated to engines, another to airframes, another to weapons, and yet another to instruments and control systems. Logistics corridors were organized so that trains and trucks would feed this network with regular precision, avoiding idle time and bottlenecks. The result, visible in these restored images, is an industrial landscape where each piece of infrastructure, from the smallest warehouse to the largest hangar-like assembly hall, exists for one purpose only: to keep the flow of weapons uninterrupted, 24 hours a day. Inside one of the largest halls, the camera moves slowly between high racks stacked with metal. On one side, sheets of aluminum lie in orderly piles, their surfaces dull and slightly oxidized, waiting to be transformed. On another, bars of alloy steel, labeled with markings indicating their composition, length, and intended use. Nearby stand pallets with semi-finished parts, spars with holes already drilled, frames roughly shaped to the curved contours of a fuselage, rings and brackets destined to reinforce critical points of an aircraft structure. Workers consult printed sheets and sturdy binders, where drawings and specifications are preserved in protective covers. Measurements are precise and non-negotiable, tolerances narrow, even though the instruments are analog and the calculations done by hand or with mechanical aids. The transformation from raw metal to functional weapon begins at the presses and forming machines. Sheets of aluminum, lifted by cranes or guided manually over rollers, are placed beneath massive stamping presses. Operators step to the side, pull levers, and the enormous ram descends with a measured but irresistible force. The sound is deep, almost like a muted thunder, followed by a slight shudder in the floor as the press completes its stroke. When it rises, the sheet that entered as a flat rectangle emerges now as a curved panel, pre-formed to become part of an aircraft's skin or an internal rib. Workers inspect the newly shaped piece, comparing it to reference templates made of wood or metal, checking not only dimensions but curvature, alignment of holes, and quality of edges. If acceptable, the part is marked and sent onward. If not, it is set aside, a small but necessary loss in the pursuit of structural integrity. In another part of the hall, rows of lathes extend as far as the camera can see. At each station, a machinist stands ready, his hand steady on the controls. Metal bars are mounted in the chuck, and as the machine starts, the workpiece rotates with increasing speed. Cutting tools approach the spinning metal, shaving off curls of shining material that fall in spirals at the base of the machine. The operator watches the dials and gauges, adjusting feed rate and depth of cut to achieve exact diameters, critical for components that must fit together with minimal play. Here are produced shafts, bushings, pins, elements of landing gear, components of guns, and parts of engine assemblies, each dimension checked with micrometers and calipers. There is no digital display, no automatic recording of results. All depends on the careful reading of marks on analog scales and the discipline of recording numbers by hand. Nearby, milling machines cut grooves, slots, and precise surfaces into blocks of metal. The work is repetitive, yet never careless. Each block is clamped into place, aligned using gauges and stops, and the rotating cutter advances methodically. The operator listens to the machine's sound as much as he watches it. Slight changes in tone can indicate excessive load, incorrect feed, or impending tool wear. Chips accumulate on the workbench, swept away periodically into bins, where they are gathered for recycling. These chips represent hours of machining, the gradual removal of material until only the necessary form remains. From such blocks and billets will emerge the housings for gearboxes, the bodies of machine guns, the casings of hydraulic pumps, and other parts vital to the functioning of aircraft and ground weapons. As these smaller components move through the plant, they converge towards sub-assembly stations, where teams of workers bring together what the individual machines have shaped. In one area, we see benches lined with partially assembled gun mechanisms. Springs, bolts, triggers, and locking parts are laid out in neat rows, each in its assigned place. ready to be integrated. Workers sit or stand, depending on the station, and with practiced gestures select one piece after another, fitting them together according to diagrams imprinted in their memory. Screwdrivers tighten fasteners to specific torque values, judged by experience and by simple torque tools, while hammers with soft heads make minor adjustments where metal meets metal. When a mechanism is complete, it is tested by hand. The bolt is drawn back, the trigger pulled, the safety engaged and disengaged, all to ensure that, once installed, it will function without hesitation. Elsewhere, larger structures begin to take shape. The skeleton of an aircraft's wing, for instance, starts as a series of spars and ribs laid out in a precise pattern atop a jig table. These jigs are heavy steel frames built with great care because they define the geometry that must be repeated in aircraft after aircraft. Along the length of the jig, workers position the spars, long beams that will run from root to tip, and between them they fasten ribs, shaped to give the wing its aerodynamic contour. Clamps and supports hold everything in alignment. The workers move systematically along the structure, drilling holes through layers of metal where needed, and inserting rivets that are then hammered or squeezed into place. Each rivet represents a permanent bond, and thousands are required for a single wing. The process is noisy but controlled, the repetitive pounding forming a background rhythm that blends with the rest of the factory's soundscape. In another hall, we encounter the heavy work of forging. Here, the air is warmer, the light slightly dimmer, punctuated by the glow of furnaces. Bars and billets are heated until they reach the right temperature, their dark surfaces turning to orange and then to bright yellow. Forgemen, guided by experience, judge the readiness of the metal by its color, by the way it responds to the hammer and the die. Using great mechanical hammers and hydraulic presses, they shape the softened metal into stronger, denser forms, ideal for components that must endure extreme stress, landing gear struts, connecting rods, critical fasteners. Each blow of the hammer forces the grain of the metal into more favorable orientation, giving it strength that simple machining could never provide. The finished forgings, still warm, are examined, cleaned, and then passed on to be machined to final dimensions. The constant movement of materials in such a factory is not left to chance. Overhead boards and clipboard schedules record the progress of each batch, stating where it must go next and when. Runners, often carrying stacks of forms, move between departments, ensuring that instructions are clear and that no station is left idle for lack of work. In dedicated rooms, planners update charts showing which machines are occupied, which orders are behind schedule, which shipments are expected. They calculate how to keep the entire system balanced so that the flow of components to the final assembly lines never stops. The aim is not speed for its own sake, but continuity. A machine that rests is a potential delay in the delivery of weapons to the front, and idle space is a luxury that war does not permit. As we are drawn deeper into this world of controlled repetition, the camera brings us to another critical area: engine production. The heart of an aircraft or many ground vehicles lies in its engine, where metal and fuel combine to generate the power that will carry the weapon to its mission. In dedicated workshops, engine blocks, crankshafts, cylinders and pistons are treated with a level of care that borders on the meticulous. Blocks are machined until their surfaces are flat to micron-level tolerances. Cylinder bores honed until their interior finish meets exact standards. Crankshafts rotate slowly on supports, while inspectors use gauges to verify that each journal sits within acceptable alignment. Here, the consequences of carelessness will be severe. An engine that fails in flight or under combat conditions is more than a mechanical problem. It is a lost aircraft, a lost crew, and a mission undone. Craftsmen assemble these engines step by step. Bearings are fitted carefully, lubricated with measured quantities of oil. Pistons, each paired with its connecting rod, are inserted into the cylinders, their rings compressed and guided into position without scratching the surfaces that must hold combustion gases at bay. Valve trains are assembled with springs and rocker arms, each piece moving within strict mechanical relationships that must endure thousands of cycles per minute. Magnetos, carburetors, fuel pumps and oil pumps are mounted and aligned, forming the systems that will keep the engine alive in the air. Throughout this process, gauges and templates reappear, instruments of trust in an era before electronic monitoring. The engine is treated almost like a living entity being built from inert pieces, and every bolt tightened, every surface checked, contributes to the reliability the pilots will depend on. Before these engines are allowed near an aircraft, they undergo rigorous testing. In special test cells, engines are mounted on stands, connected to fuel lines, coolant systems, and exhaust ducts. Protective glass separates the test cell from the control area, where technicians watch carefully. The engine is started, often with some hesitation as fuel fills the lines and oil circulates. Once running, the noise is enormous, even behind thick walls. The engine is brought through different power settings, from idle to maximum output, while instruments record temperature, oil pressure, fuel flow,